Hi students, in Mathematics 1B of Intermediate, one long answer type question is expected from the concept maxima and minima. That is from the chapter Applications of Derivatives, exercise 10H. There are 6 most important questions which have been repeatedly asked in the board exam. In this video, I will be explaining one of those 6 questions. In the coming videos, we will learn the rest of the questions. We are going to learn how to solve this question. Please go through the question once. According to the question, there is a rectangular sheet. Let ABCD be the rectangular sheet. The dimensions of the rectangular sheet are 30 centimeter and 80 centimeter. From each corner, 4 equal squares are removed. The side of the square is x centimeters. All the squares are equal. Side of each square is x centimeter, and these squares are removed from each corner of the rectangular sheet. Now just imagine what would be the shape of the figure after removing these squares. We have to write what is given in the question. So in the given we can write ABCD is a rectangular sheet of dimensions 80 centimeter and 30 centimeter. Square of side x centimeter is removed from the corners of the rectangular sheet. After removing the squares, we get this figure. Now just think about the new length. The new length would be 80 minus 2x. Why? Because we are removing 2 x's from the total length 80 centimeter. In the same way, new breadth would be 30 minus 2x. On folding these 4 parts, this one and this one, on folding these parts, you will get a rectangular box. So the height of the rectangular box will be x centimeter. Now if you read the question, it says that the sides are turned up. It means these sides are turned up. If you further read the question, after turning the sides up, a rectangular box is formed. Rectangular box is formed. Rectangular box is in the shape of cuboid. Cuboid is a 3-dimensional figure. It has length, breadth, height. Length is 80 minus 2x. Breadth is 30 minus 2x. Height would be x. As we are turning the parts up, sides up, height would be x. So we got the dimensions of the cuboid and we can apply the formula of volume. Volume is L into B into H. He is asking to find the greatest volume. So we can apply the formula V is equal to LBH, from which we can get the function. Now let us write all this information in proper steps. Here I have written 3 steps. Let's see the first step. On turning the sides, we are getting a rectangular box. Rectangular box is in the form of a cuboid. The dimensions of the cuboid are length is equal to 80 minus 2x, breadth is equal to 30 minus 2x, height is equal to x. Now volume of cuboid. V is equal to length into breadth into height. On applying this formula, we get the function in x. Now let's find the volume of the cuboid. Let us substitute the values of L, B, H. On multiplying first two terms, we get 2400 minus 160x minus 60x plus 4x square and into x. Let us simplify these two terms. We get 2400 minus 220x plus 4x square. Now lastly, let us multiply with x. We get 2400x minus 220x square plus 4x cube. We can take this volume, expression of this volume as f of x. So our function will be 2400x minus 220x square plus 4x cube. So this is the function we got. We can complete the problem from here on in few steps. Firstly, we have to differentiate the function with respect to x. That is, we have to find f dash x. On equating f dash x with 0, we get the value of x. In the question, it was asked to find the value of x for which the volume is greatest. To get the maximum value of x, we have to find f double dash x, that is second order differentiation of the given function. If f double dash x is negative, that is less than 0, we conclude that x is maximum. In case f double dash x is positive or greater than 0, we conclude that x is minimum. So let us first start the differentiation. differentiating with respect to x. F dash x is equal to 2400. Differentiation of x is 1. Differentiation of x square is 2x. Differentiation of x cube is 3x square. So f dash x is 2400. 222s are 440x. 4 3s are 12x square. To find the value of x, let us equate f dash x with 0. So 2400 minus 440x plus 12x square is equal to 0. On dividing with common factor. What is the common factor here? 4 will divide all the terms. Let us divide with 4 throughout. We get 600, 110x, 3x square is equal to 0. So we got a quadratic equation in x, which is 3x square minus 110x plus 600. Let us solve this quadratic equation to find the value of x. We can find the value of x by factorizing this quadratic equation. On multiplying x square coefficient and constant term, I am getting 1800x square. I have minus 110x in the middle. Now let us split 1800x square into two parts. Minus 90x, minus 20x are the factors. Now let us write the middle term as minus 90x and minus 20x. The 600 is equal to 0. Let's take common in the first two terms. 3x is the common. X minus 30 will remain. In the next two terms, we can take minus 20 as the common. X minus 30 will remain. As you have taken minus common, this plus would become minus. Let's take x minus 30 as common. 3x minus 20 will remain. Product of two terms will be 0 only when one of them is 0. Either this must be 0 or this must be 0. Only then we can get the product as 0. So let's equate both the terms with 0. So I am getting x as 30. The other value of x is 3x minus 20 is equal to 0. 3x is equal to 20. X is equal to 20 by 3. So we got two values of x. X is equal to 30 is not possible. Why? Because in the rectangle, if you notice, in the rectangle, breadth was 30. So we were removing two x's. In the corners we were removing two squares of side x. So just think, how can we remove two 30s from this breadth? If it is done, if it is so, then this rectangle might not have formed. So we can't remove two 30s from 30. So on this basis we conclude that x is equal to 30 is not possible, as breadth itself is 30 centimeter. So the x value is 20 by 3 centimeter. To know whether this is maximum or minimum, we have to find f double dash x. So let us find f double dash x. This is f dash x. Let's find f double dash x. Differentiation of constant is 0. Differentiation of x is 1. Differentiation of x square is 2x. So f double dash x is minus 440 plus 24x. We already got the value of x, which is 20 by 3. Let's substitute. So minus 440 plus 24 into x value 20 by 3. 3 8s are. So f double dash x is equal to minus 440 plus 160, which is nothing but minus 280. So f double dash x is less than 0. We are getting a negative value, that is less than 0. So the volume is greatest at x is equal to 20 by 3 centimeter. That's it.